All right, one more topic. This is called rationalizing denominators. Now, one thing about square roots is that we never want to leave them in a denominator because they don't represent a whole number, which is what we want a denominator to be. So, we want to get rid of our friend, the square root of 18, and turn him into something a little bit nicer. What we're going to try and turn that denominator into is any perfect square. A lot of people are shown how to do this by always just using the number they see in the denominator and multiplying as a fraction, for example, the square root of 18 over the square root of 18. Now this will work, but it'll be quite slow. So instead what we're going to do is we're going to ask ourselves, can we turn the square root of 18 into any one of these numbers? And I think that the square root of 18 would go nicely with 36. If we multiplied the bottom of the fraction by the square root of 2, we would get the square root of 36 on the bottom. That's a whole number. Now, you can't just go multiplying fractions denominators by things without also multiplying the numerator by the same thing. Whatever you do to the top of a fraction, you also have to do to the bottom, or vice versa. So here we would get 18 root 2 over the square root of 36. Again, I know the square root of 36 is 6. So I have 18 root 2 over 6, which will reduce down to 3 root 2 over 1, because that's what this fraction, 18 over 6, is. Sometimes you'll have both a radical in the numerator and the denominator. It's still the denominator we focus on. So if I take the square root of 3 and I multiply it by the square root of 3, I'll get the square root of 9. I have to do the same thing on top as well. So I would get 5 square roots of 6 over the square root of 9, or 5 square roots of 6 over 3. That can't be simplified any further, so that's my final answer, 5 square roots of 6 over 3. Thanks for watching.